All right. In this chapter, we're going to talk about routing concepts, initial configuration of a router decisions, and router operation. Then we're going to start talking about a little bit about static routes. Y'all remember in Packet Tracer 11 you had to do a default route and a static route. Well, I'm going to discuss with you what that is and how you do it. A lot of you didn't get 11 in, but I'm going to extend that deadline for you since you didn't have this last week. Aren't I being so nice? Okay. We're going to configure a router to route between a multiple or singular networks. We're going to describe its functionality and features. We're going to explain how they use that information to determine how they're going to forward the packets, what encapsulation versus de-encapsulation is. We're going to talk about different way a router builds a routing table. Think of routing table as a phone book. Okay, as long as you keep that concept going, you'll be all right. What a rotating entry is for directly connected networks, how you see it and how it works. And this phone book analogy, I'm going to keep for the rest of the semester when we get into RIP, when we get into EIGRP, and when we get into OSPF. Okay. We're going to talk about how it uses that to do dynamic routing protocols, which is EIGRP, OSPF, or RIP. And then how we do routing with static routes. Okay, we're going to talk a little bit about that. Well, what is the characteristics of a network? Of course, you're going to have topology. You're going to have the speed. You're going to have a cost, security, the availability, the scalability, the portability, reliability. Those are all characteristics of a network, right? Y'all have seen this many times up in your Network Plus class, right? Well, who is responsible for passing traffic? It's a router. Okay? This guy right here is what we call a routing table. This is your phone book. This tells you where all your connections from your router go. Okay? In this case, we have a directly connected fast Ethernet out of one side, which is going to right here. That means this whole entire subnet is going to be the 192.168.1.0 subnet. And then the one that's going to go out the serial, coming over here to this switch, which you'd never have a serial into a switch, is going to be the 192.168.2 network. Does that make sense? So, being able to see what interface that it's going out of will tell you what network it's going to. Does that make sense? A router is basically just a computer. It has the CPU, it has RAM, it has an operating system, and it has other different things. RAM, what does it state? Is it volatile or non-volatile? Think about it. Hardware class. Is your RAM volatile? Speak up.
Yes.
Okay. ROM, flash memory, they're non-volatile. Why? Because they store it onto a flash memory card. Okay, same thing with NVRAM. NVRAM, non-volatile RAM, all it is, it stores your startup configuration file. So that is the initial configuration that gets loaded into your system upon boot. All right? ROM, it contains a limited amount of IOS, enough to boot the IOS. Think of it, your ROM is where your master boot record is. It gets all the technical facts, the boot up instructions, the diagnostics, where it does the post, and it boots into flash. Flash is the memory where the iOS is stored. Does that make sense to y'all? Y'all kind of remembering some of this from hardware, right? All right. Routers, like I said, are computers. They have ports. We have WICs. We have flash cards. We have mini NICs. We've got auxiliary port, console port, USB ports, LAN interfaces. We can have a WIC. All right. But what is a purpose of a router? It interconnects. It's the device that interconnects multiple other networks together. So if you're at home, what is the last device you see? Before it hits your cable modem and goes out, what is the last device it'll see? The router. Comes through the switch into the router, and they may be in the same device, and then the traffic goes out. Okay? Routers choose the best path to get there. So, I use this analogy very loosely. Okay, I'm going to call Casey. But in order to call Casey, it's got to go through Josh or it's got to go through Derek. Which is going to be my best method? Josh, because he's sitting right next to Casey. Derek would have to raise his voice to get the information to Casey, right? And we call that attenuation. Because he has to have a stronger signal to get to Casey than Josh does. So that's a tidbit of information that you probably didn't think about. What's the difference between a static route and a dynamic route? A static route we have to configure manually. Anytime you see static, that means you're doing something manually. Dynamic means it automatically comes into play. Right? Well, we'll get into the dynamic routes a little bit later on. Routers use these routing tables of the phone book to find out which is the best way to get there. So if I'm trying to find out Casey's phone number, what is going to be the best way I do it? I look at, well, if she's on the other side of the world, it ain't going to work that easy. I get the phone book, I open it up, and I start looking. Well, I know Casey lives in Oklahoma City. I don't know where you live, I'm just saying. Going into the phone book, I look underneath Oklahoma City, right? I pick up an Oklahoma City phone book. Then I say, oh, what is Casey's last name? I know it starts with an M. Oh, yeah, that's right, it's Mills. So I flip through the book and find Mills, right? Once I find Mills, then I look, oh, Casey's not here. What would her dad's name be or her mom's name, right? And then how they used to do it? When you're looking for to call up a girl for a date, you'd have to figure out what the parent's name was. You know, even if you're in a small town, you probably have 15 of the same of the last name for that girl, right? Yeah, Josh and Chris and Nick all smiles. They know what I'm talking about. And Casey knows how many guys have tried that trick with you. And so anyway, you get through the phone book and you get that number, okay? Same thing with the routing table. I'll look at the routing table and say, all right, if I need to get to Casey, I know I've got to go up 15th Street over to Sooner, to go down to 29th, to shoot across on 29th, all the way over to Bryant, then come back up into a neighborhood. All right? Not that I have any clue where you live. Don't think that I'm trying to give you directions to our house. Even though I could find out that information because I have access to it, but that's not what I'm here for. The routers encapsulate the packet and forward it to that interface to go out. Okay. Now, I haven't really talked to you about the OSI model. Y'all do remember that, right? And it encapsulates as it comes down. Well, if it gets to layer 3, what is layer 3? It's your network layer. What's on the network? What protocol? IP. So if I have my IP protocol on layer 3, what's my PDU? What's the data unit that I'm using for that protocol? You hear the term all the time. IP packet. Thank you. What are we sending? Routers are layer 3 devices, right? So what do layer 3 devices send? Let's try that again. What do layer 3 devices send? Thank you. All right. As we were coming down the OSI model, right, we had our application, presentation, and session. All of this is just straight data. Everyone with me? Then we had our transport layer, our network layer, our data link layer, and our physical layer, right? I'm going to show you a neat little trick. Other than please do not throw sausage pizza away, because that's my favorite. You caught the acrostic there? Please do not throw my sausage pizza away, except I added an N, or an M in there. On physical, if I'm going across the physical medium, is that not where the physical addressing is, right? On physical medium. What traverses a physical medium? That is the medium. What are we sending? Data, but what form does the data write on?
Electrical current.
Yes, but if you look at the electrical current, what form does it have? Binary, which means it's 1 and 0, right? We call that make sense? Actually, I probably need to put another 0, 1 out here. So I have my 8-bit. Okay? Data link is broken into 2 different areas. Okay? We have our media access control and we have our DLLs. Okay? How many of y'all have heard the DLLs in Microsoft? Do not confuse it with the data link layer. Okay? They're 2 separate things. It's a file extension in Windows, but DLL is where you start to get into your network. But if I'm on the data link, what's my hint? What kind of information is on a layer 2 device? If I'm a layer 2 device, I'm a switch, right? A switch sends what we call frames. Y'all familiar with that? So it sends frames. But what is a frame? It carries the physical address of the system, or the MAC address. Does that make more sense now? Y'all seeing where this is coming into play? So on the network, we're on the network layer. Remember, this is layer 1, this is layer 2, 3, and 4. These are what we mainly deal with in our field. Layer 3. What type of device? Okay. What type of device is a layer 1 device? It's going to be your media or your medium, your cable, your physical infrastructure. Okay. Layer 2. What type of devices do we have? Switch. You hear layer 2 switch? Give me a layer 2 switch. If I say give me a layer 3 switch, what am I talking about? Can you have a layer 3 switch? Absolutely. All layer 3 switch does is it gives it some routing protocols that can be done. I.e., your home router is a layer 3 switch. It provides routing capabilities. Even though they call it a router, it's a layer 3 device because it does switching and routing on the same device. Okay. Layer 3. What kind of protocols are we using? IP packets, right? If I'm sending packets, what am I sending it on? I'm sitting on a router. All right? Everyone with me? Now, on transport layer, what protocol are we talking about? No, it's UDP or TCP. We're talking about TCP or UDP. Uniform Datagram Protocol or Transmission Control Protocol. What these do right here decide whether I am connection bound or non-connection bound. If I'm talking to Casey on the phone, what kind of traffic do I want to have? I want to have a connection, right? So that I know that Casey can hear me loud and clear, and until I hang up or she hangs up, that phone call is going to go. UDP is what's on your TV. It's going to flood you with packets. And that's why you'll have pixelations throughout your TV occasionally. It's because you've lost some packets that didn't make it. Okay? That's what UDP is. It's connectionless. That means you just say, hey, I'm telling you you're going to have a midterm tomorrow. Okay? I have flooded all y'all with that information. Well, Josh is the only one that needed to know it. That's UDP. It's connectionless. No specific connection. What we have on here is what we call segments. Okay? As you're coming down and you're encapsulating the protocol, we have our data, right? Pretty simple, right? Well, when we get to the transport layer, we have to do what we call segment it, so that we're taking it from 2.4 gigabytes down to 1500 bits so that we can transport it, right? So what we do is we segment it. Are y'all understand that concept? So now that we've segmented it, packet 1, packet 2, packet 3, packet 4, right? Y'all are following me along. We've segmented it, now we're sending it into 4 different packets. It goes down to layer 2. Or I'm sorry, in layer 3, what does it tell me? Anyone know what layer 3 does? What does it give me? If I have the physical address, which is the MAC address, what do I have here? And my IP address, which is our logical address. So layer 3 is logical versus physical on layer 2. Y'all starting to see this translation here. Is this helping a lot? I just want to make sure. Okay. We have the logical and the physical. So we've broken this data packet into 4 different subpackets, right? Well, when we come down here, all we're doing is we're going to encapsulate this D. On the front side, we're going to put a header, and then we're going to put a trailer on each side of these. The header tells me where am I going to send my packets, right? Giving me my physical address, and here I have my IP. So when it comes down to the bits and it shoots it over to this first switch, it comes up to the switch. This MAC address isn't on mine, so let's take it up to the physical. Well, okay, it needs to go out this network, so we're going to send it out that signal. That is how it works. That's why you keep going like this, and your transfer rates keep going higher and slower. Does that, y'all with me on this? Routers choose the best path to get there by taking the information they have on the data at the bit level itself and breaking it back up the string. Okay? Routers will return this information to this table so that it says, okay, I'm looking for 192.168.20. Well, it tells me I'm directly connected to 192.168 out of serial 000. Where's serial 000? It's going to be right here, connecting to here. So it's going to come to this path over here. That's where that packet's headed. That make sense? We have 3 different types of forwarding mechanisms. Okay? We do process switching, which is an old way that we don't ever use anymore. Then we use fast switching, which basically it stores it and forwards it. Y'all hear that concept, store and forward, quite a bit. And now we have what they call Cisco Express Forwarding, where it takes the entries that are non-packet triggered and just sends them on. So what it does, the first packet comes in, hits it, goes out. Second it comes in, boom, boom. And they can take multiple at the same time. That's what we call express. Hit that express lane, right? Here's the sample LAN and WAN. Why do people think that a WAN is a collection of LANs? Huh? WAN is a collection of LAN. Well, what is a WAN? Well, it's everything out here, right? In this drawing. Essentially, this actually should come through here into here. All these are connecting over this cloud that has many routers in between. So when you hear this, how many of y'all have done a ping or a trace route before and it says time to live is 20-something or 30-something? You know what that means? Every time it hits a device, it loses one. Seriously, that's what time to live means. After 28 times, it drops it. If it doesn't get to your end by 28, packet's gone. Exactly. Yeah, it's not seconds, it's how many hops. Okay, default gateway. What is a default gateway? Y'all have heard that term many times. Does anyone know what a default gateway is? Speak up. It's the what? Exactly. It's the address that will get you to the external environment. That's all it is. So in this case, it's going to be 192.168.1.1. That is my default gateway. Why? It's this IP address that will get me out. We talked about documenting network addressing, right? We spend a lot of time on subnetting. I think that's what scared a lot of people away, is that subnetting. Was that really that mean? I'm always mean, Marlene? I'm not teasing when I'm going to fail you. See, and I even got a recording on it, so now I have to.
That was Marlene.
Marlene, not Marlene.
Exactly.
All right. What's the difference between a static assigned versus a dynamic assigned? Like I said, a static assigned is something you have to take an action on. Dynamic is something that will automatically occur. Does that make sense? So anytime in any device that you hear static versus dynamic, static means something you have to take an action on. Dynamic means something someone else is taking an action on, or something is taking action on. DHCP is usually acquire that through a server and or a router that will do a DHCP for you. Okay. Device LEDs. All right. We have different lights that do different things. If the light comes on next to it after you connected something to it, it's probably telling you it works. Okay? If you're on a gigabit port like we have over here, you plug it in. If it blinks one and gives you a pause, you're 10 megabits. Blinks twice and then pause, you're on 100 meg. Blinks 3 times and quits, then you're going to be on a gigabit. Does that make sense? Because you have your S and your L. Your L is your link. That means you actually have something that's going to usually be an amber color. And like I've got on back of some of these computers, if you turn around behind you and look at the computer behind you, you can probably see the amber light on. Notice it's totally on. There's no traffic being forwarded at this time because you're not seeing any greens flashing, right? You may see some greens flashing. That'll give you the link speed. Did y'all know that? You just thought it just meant there was activity, right? Okay, some different types of cables that you need to be familiar with. Y'all know what a USB cable is, right? At least I'd hope so. Y'all know what a serial port is, right? DB9 connector. You see the cable required to it is going to be a RS-232 to serial, or it's going to be a console cable, one of the two. And you'll plug that into your console. That means that allows me to telnet into this system to do any management I need to do. That's what a console port is. For example, if I wanted to do, and this is for if I'm setting up an interface, VLAN 1, that would be on a switch. Your VLANs are always going to be on your switches. I type in my IP address, 192.168.10.2. My mask is 255.255.255.0. I do no shutdown. Why? Because by default, everything is administratively shut down. Each port is. Until you turn it on. You turn it on by telling it no shutdown. And every time you do it, trust me, you can shorthand it and say no shut, and people are going to think you said something else. And if you misspell it, like 99% of you will do the first time you do it, you're going to be sitting there waiting 5 minutes while it tries to translate it. Okay? Basic router configurations, we're going to do enable secret class. What that does is that tells me when I log into my system, my enable password is going to be encrypted, but the password name is going to be class. Line console 0, that means if I'm trying to console into my console port, my password would be Cisco. Login, that means that port is now turned on so that you can log into it. Same thing with line VTY, that's your terminal lines. That means that people are trying to remote in from a distance, that's how they can get in. And the service password dash encryption means that all my passwords on the line and the VTY are now encrypted. Okay? Interface gigabit Ethernet 00, you can just put interface G00 or int G00. Cisco lets you shorthand quite a bit. Description, you type in the word description, you can give it any description you want to for that port, okay? IP address, again, anytime you have the IP address, it's going to be IP space address space, it's IP address space, it's subnet mask. All right? Again, you're going to no shutdown, then you're going to do exit. That's why you see these little things up here that say interface up, or change state to down, then change state to up. Yes?
Real quick, you don't do a gateway there?
No. The only time you'll do IP default or IP space default dash gateway is on a switch. The router already doesn't need it. Your PC, you're telling it to go out this port for it to be the default gateway. Okay? To do an IPv6 address, it's the same way. You're going to go in with the description, go into the interface, do an IP address, IPv6 address, and then type out its address. Okay? So if the packet tracer tells you to do an IPv6 address, how are you going to type it in? Just what you see. That's why I get these out there for you, so you can go back and have reference material on it. Because you notice you went from 11 down to like 6, right? That means all those packet tracers started weighing a little bit heavier in this class. Good news is I'm not going to have you do any IPv6 on your final. Okay? Your loopback address. What is the loopback address? It's a test address. Okay? Again, loopback is int loop 0. Once you do that, you'll get you see the C and the L, L being your loopback address. Anytime you want to see the routing table, you go back just to your enable prompt, which would be show IP route, and it'll give you your routing table. Okay? As we get further along, we'll go through that. Same thing, if I want to see my IPv6 addresses, show IPv6 interface brief. It's going to show me all the IP addresses, all the IPv6 addresses for each interface. I can do all sorts of different types of subsettings if I wanted to. I'm not really going to go into them, but you can pipe it to exclude, include, section, or begin at a certain point. So if I wanted to exclude Casey from the class, I'd pipe it to exclude Casey, right? Sorry, Marlene. Is that you? Coughing.
Me coughing.
Oh, it's you coughing. Okay. Here's the encapsulation, de-encapsulation process I was talking about. Does that make sense? Now that you can graphically see a lot better than what I can draw. You start with layer 7, go all the way down to layer 1. It gets to the first router, goes up, reads at layer 3. Why? Because the router is on what? Layer 3. So it goes up to the layer that it's on, reads it, comes back down, goes to the next router. Goes up to layer 3, goes down. Goes up, comes out to layer 3, goes down. Layer 3 says, oh, you need to go over here to the switch. It'll come up to layer 2. Layer 2 reads the MAC address and sends it on to the MAC address. Does that make sense? Then it comes back up from the bits all the way back up to layer 7 so you can get where you need to go. Isn't that pretty cool? Okay. This is just, I'll let you go back through, but I already talked about it, the encapsulation process. That's really strange. Based on routing decisions. Best path. Okay. When we're talking about the dynamic routing, we're talking about RIP. It's based on that hop count that I was telling you about, the time to live. OSPF deals with some bandwidth issues, and so does EIGRP. Load balancing. That's the cool stuff. If someone's hogging all your bandwidth, you can do load balancing so it averages out. Administrative distance. This is one that you're really going to want to know. So mark it down, slide 36. A static route has administrative distance of 1, is more reliable than an auto-discovered EIGRP with administrative distance of 90. Why? Because you know it's there. You assigned it to be there. What if I have a AD of 0, which means it's directly connected? They're going to be better than one that's assigned. Okay? Remember, routing tables are only stored in RAM. And there's some different things you can look at if you want to. Not going to get to it. Okay. Let's look at an entry. D. It identifies how the network learned by the router. In this case, D is for direct connect. Okay? The pink identifies the destination network. Where's it going? Does that make sense? The orange, dark orange, defines it as the administrative distance, or how trustworthy is that site. It's a 90. So what did we just call a 90? EIGRP, right? Purple, the metric. How long of a distance is it going to be to reach that remote network? And we'll talk about those a little bit later on. The tannish color, the salmon color, identifies the next hop. So I'm going to, if I need to go to the 1010 or 10110 network, it's going to go out of 209, 165, 200, 224. So as you can tell, if I'm sending a packet from over here and it hits this router, it's going to go out this port to get over here to get to these 10110s. Does it make sense? The elapsed time since the last network was rediscovered. Okay? And then finally it tells you what interface is going out. In this case, it's going out 0000. Y'all think y'all can read IP addressing tables, right? So if I threw a couple of these up next week for a pop quiz, would you be ready? You might want to be. We have a link local or direct connect. Okay? Those are just ways to look at directly connected interfaces. All right? I'm not going to cover that again. Static routes. All a static route is you say IP space route space the destination address, which would be its IP address and its mask, and then what port is it going out. That's it. That's how you assign a static IP address or static route. A static route is going to be the IP route, the network, its mask, and what interface it's going out, or the next IP address that it hits. That's all it is. Default static route example. We have a static route of 000, out 0, going directly connected to 0. What that means is all traffic that hits this router is actually going to go out 0000. That's all it says. All right. Again, static route on the other end. 192, 168, 10, and 11 are both connected to this going out this port. Right there. Dynamic routing. All it is EIGRP, RIP, or OSPF talking between the two routers saying, here's what I've got on my side. What do you have? I like to call them the nosy neighbors. Because they're always saying, hey Josh, who's sitting next to you, man? What's the phone number of the person sitting next to you? Hey Josh, what's the phone number of the people sitting next to you? 10 seconds later. Josh, what's the phone number of the people sitting next to you? Seriously, that's what it does. Dynamically.
Very good router.
No, it does it every 30 seconds. But the dynamics are going to be your IGRP, OSPF, ISIS, not ISIS, and RIP. Trust me, I had people talking about that last semester. Oh, you must be a terrorist. You have ISIS on here. No, I have is. Okay? IPv6. Version 6 of IP addressing. You're going to use RIP-ing, which means for RIP Next Generation. OSPF version 3. MP BGP, which is Multicast Protocol. Border Gateway Protocol 4. And EIGRP for IPv6. So notice the difference. You caught those four? Ripping EIGRP version what? Any questions on chapter 1?